is for 35 years of excellent service as the South African Astronomical Observatory, as well as the successful construction of the Atlas Asteroid Hunting Facility in Sutherland. And number 2, the Shield for the Order of the 74, Issue 3 of 74, for extraordinary service to the South African Astronomical Observatory, ladies and gentlemen. I think you've heard enough from me for tonight. Please, gentlemen, the floor is yours, and thanks again for joining us tonight.
Right, thank you, Kari. And as you can hear, is this working? Yeah. Okay. As you can hear, tonight the presentation up to grade 8 will be me, and matric and onwards will be Willie. So yeah, I'm Johan Leroux, I'm the other one. So as you said, in this presentation we will explore the influence of history on navigation at sea, the influence of the moon on the oceans, and space-based technology and research. So I will talk about how to determine where south is by using the stars and now the pronouncement, Magellanic Clouds, Ferdinand Magellaanse wolke. So this will typically be a photo, if there was photos those years, way back just after Jan van Riebeeck arrived here, of Cape Town, and then the night sky over Cape Town, most probably from Bloubergstrand. And you'll see a few ships, but most of all, you'll see a lot of stars. This is a time before Eskom, or is it now after Eskom, I'm not sure. So you'll see the Milky Way, and you see the 2 Magellan clouds that's here. So if you look at the night sky, and there's just a lot of stars, and we want to determine direction. And that is why, in those days, they want to know where is south, because they want to navigate with their ships. And if they know where south is, then to work out where's north and east and west is easy. You guys know Morse, no? North at your back and east and west you sort out. So guys, it's going to be, what I'm going to do is really, it's the work that you did in school, voortrekkers, scouts. But you know, a lot of times I could ask, where's south? How do you do it again? So I'm going to tell you tonight, and when you go back, you can tell the grandkids, and you can tell the neighbors, and you can tell them how to get south and how to get direction. So if we look at the night sky, and we watch it for quite a while, we will see that there's movement. And as you can see on the screen, the movement is around one point. The stars revolve around a fixed point in space. And that's a point in space. And if we can determine this point, we know exactly where south is. And that, there you can see it's around that point. Let me just forward it a bit. Okay, so if I could know where that is, go to the horizon, and I know exactly where south will be. What do we call this point in the southern hemisphere around which the stars revolve? Anybody?
70.
Okay, let's try. The South Celestial Pole. Now, in the north, they're lucky. They've got a star that sits there, quite a bright star, with the name of Polaris. We in the south but nothing. Not really. If you look through a telescope, you can see, but actually, with the naked eye, there's nothing. So, if you look up, not now, because it's clouds, clouds, and clouds, unfortunately. But normally, if you look up, there's just a lot of stars. So now, the question is, where is the Southern Cross? Because it's the Southern Cross that we're going to use in the southern hemisphere to get south. Oh, one of the ways, easiest way. So, first of all, if you look south, it's a false cross. Wrong one. The diamond cross. A wrong one. The Southern Cross. The right one. How do we know it is the Southern Cross? Easy. Yes, you're right. The pointers. Now, those two bright stars, and you won't miss them, will show you where the Southern Cross is. And that was quite fast of me, because sometimes you do miss them, especially in December when they're low on the horizon. So, how are we going to determine south? 3 methods, plus 1. First, we draw a line through, can you see that will be the Southern Cross. This will be the pointers. So we draw a line through the Southern Cross and we extend it 1, 2, 3, 4.5 times, and we go straight to the horizon, and we have south. Wow, quite easy. Right. Method number 2. You know this, hey? I'm sure. So again, we have the Southern Cross, we have the pointers, and we draw a line through the Southern Cross. And now, the next one works actually very nice for the scouts and the voortrekkers, because they like swords. So you make a sword of the pointers, and where they cross, you go down, same point, south. Okay, next one. If you look up and you see the Southern Cross, and you follow that middle line, you'll see quite a bright star with the name of Arcana. Don't worry about the name, just look for the bright star in line. And what you do, draw a line through the Southern Cross to Arcana, you halve that line, same point, south. Okay, that was easy, was it? You're so silent I don't hear you. Okay, and then this two. Oh, I must stand here, This two, this is the two Magellan clouds. In the south, again, and what's significant of them? They are actually quite visible from here, from Gansbaai, from Cape Town. It used to be. Not anymore, for one reason, and that is the light pollution in the city, and the light is the lights. So if you're in a dark place, you see it quite easily, especially on the side of your eye. But if you're in towns, in the city, then it's become difficult and more and more difficult. So this is two dwarf galaxies in the southern celestial hemisphere, and they go around and around the Milky Way. The Portuguese sailor Ferdinand Magellan was the first European to describe the Magellan clouds in the year 1519. Now a bit of interesting statistics, and this is more or less and not accurate, because you can't get the accurate distance if you look at our friend Google. But the large one is 180,000 light years from us. So let's think about this for a bit. 180,000 light years. That's the closest one. That's a big one. Nah? So when I took this photo a week or 2 or 3 ago, then the light that entered my camera left the LMC 180,000 years ago. I'm saying it again. The light that entered my camera left the LMC 180,000 years ago. I hope you can still remember what you ate last night. It is 14,000 light years diameter, and then the small cloud is 200,000 light years plus minus, and 7,000 light years from here. Why was it talking about this? 3 methods, 3 methods to determine south, but we can use them as well, especially when it's cloudy, there's mist on the sea, there's a mountain in front of you, and to make a triangle between the two, and the sides that's equal, and that, if you go down, it's south again. Ladies and gentlemen, that was grade 6, now grade 10.
Thanks, Johan. Yeah, don't worry, I'm still going to pitch at the grade 6, don't worry, I'm not going to lose everybody, yeah. So I'm going to talk about the history of navigation at sea, especially in South Africa, and then the influence of the sun and the moon on the oceans. Yes. So if you want to determine your position on Earth, longitude, latitude, that is how you can find any point on Earth, and you can describe it to the next person, or you can send it to the next ship and say, come and get me, I'm right here. And that's a universal way of getting position. So in order to find your latitude, that's the easy one. Relatively speaking, Johan mentioned about Polaris, the North Star, and so in the northern hemisphere it's easy. So you take your sextant and you basically measure the height of Polaris above the horizon. And then of course on the sea your horizon is exactly level all the time. So as Ferdinand Magellan was sailing south, the Polaris was sort of dropping below the horizon. So by the time he got to the equator, it was sort of right on the horizon. And then the North Celestial Pole, which is where Polaris is right opposite the South Celestial Pole. So that's starting to rise as you sail over. And basically, so that's just roughly speaking how you find latitude. And of course, when you lose Polaris, you have to use other stars. You can use the sun and moon during the day and as well. And of course, then they needed complicated tables and stuff. So it gets pretty complicated. But basically, measuring the height of a celestial body above the horizon is easy. Longitude is a more difficult one because the Earth's spinning, and so you need to know when you left your harbor, or and of course we talk about the prime meridian, which actually runs through Greenwich Observatory in England, and that is the 0 point for latitude, for longitude. So you need to know how far the Earth has spun since it was over the prime meridian. So I'm not a navigator at all. I just know in principle. But basically, so for that you need accurate time, and of course that is why ships carry marine chronometers. and which is basically just a fairly stable. It used to be a mechanical watch, and in fact these days our crystal control watches are much more accurate than those big old marine chronometers. But they would, and in fact I'm going to talk about rating them a bit later. Yeah, so those are the two main ways of finding longitude and latitude, and that's, so when you're out in the ocean and you can only see the stars, you can actually pinpoint exactly where you are on the globe. So if we look at star positions, and the reason why I'm telling you this is we're going to talk about how they measure star positions as well. So think about the Earth, and the heavens is at infinity, and the stars are basically fixed. The Earth is turning within it, and so what they've done is they've actually taken the Earth and they just extended it onto the stars. So Johannes already mentioned the south celestial pole, which is basically the Earth's axis being extended into the heavens when it goes south. And that's why what Johan explained is exactly what we see, because the Earth is turning, and therefore the sky seems to be turning, but of course it's us moving. And then of course the same on the north. They've also taken the equator out onto the stars, and they call it the celestial equator. And of course the ecliptic, and that's the path that the sun and the moon and the planets run along. And that of course is tipped by our 23.5 degrees. And so you also have a 0 point, which we call the vernal equinox. And that's, don't worry, but that's just the 0 point for the one measurement we call the right ascension. And right ascension is the same as longitude, again, the second one that we mentioned just now. And declination is the same as latitude. I always yeah, declination is latitude. Yeah. Don't worry. you know what I mean. Yeah. So basically, to tell your pal your star is there, you again have the same system. Basically celestial longitude, latitude, if you think about it, which we call the right ascension and declination. It's just the same thing taken out to the stars. And therefore it doesn't matter where the Earth is near that point, you can also get that position. So the same as we had with longitude, you need accurate time. To determine right ascension, as again the one that turns, you need sidereal time, which is basically star time. So at our observatory in Cape Town, if you walk into the main office, you will see these two clocks, and the one is the sidereal time clock, and the other one is mean time, which is the same that we use on our watches. I'm not going to try and explain sidereal time, but it is basically it is due to the Earth's movement around the sun as well that you have to add in. But I'm not going to confuse you even more with that. Just an aside, you all know the story, Dr. Livingston, I assume. I presume was the famous words. So before he went into Africa to go and do all his exploring of Africa, he actually came to the observatory in Cape Town to learn to navigate, and especially reading an sextant and whatever. And he actually presented the astronomer at the time, Sir Thomas McClure, which we know from the town of Maclear and Maclear's Beacon on Cape Town, with a special walking stick, which we sort of still have there. But if we turn the clock even further back, and we've heard about Magellan who came down to explore. These people actually had to navigate because they were out on the ocean. In the beginning, they actually just followed the coastlines and just stayed within seeing distance from the coastline. and that was an easy way of, but that's very ineffective, because you need to follow a very long line where you can just take a shortcut. So as they got more and more brave, of course, they needed accurate star charts to do their navigation, and therefore they ended up with a lot of shipwrecks. There weren't many, especially sudden star charts, because everything happened in the northern hemisphere, where they knew the sky well, but down south they didn't know. They didn't have any accurate star maps. The position of the coastline was even badly known as well. So the first effort really that we know of that's been recorded was in 1685, where this Father Guy Taccard, he was a French guy, a French priest, and a missionary, and a mathematician. He came over, he set up an observatory in Cape Town. In fact, you saw the picture there. And he did some explorations or some measurements, and he saw that a lot of the sudden stars, the stars that were given on the maps of the day, didn't exist, and then very bright stars weren't on the maps, and worst of all, the coastline of South Africa was 300 kilometers west of where the map said. So it's no wonder they had so many shipwrecks. So he did some rudimentary measurements, and then he was followed up about 75 years later by the Abbey. Again, Abbey is a priest, Nicolas Louis de la Caille, and he stayed in the Cape for 2 years, and he set up an observatory in what was Waterkant Street. And you know why it's called Waterkant Street? Because it used to be next to the water, you know. So and he did some measurements. He was an amazing person. He died fairly young. But really, the stuff that he did in just these 2 years at the Cape, this is just a few. But the most important one is to measure the positions and the brightnesses of about 10,000 stars. He determined the longitude of Cape Town using Jupiter's moons. He determined he measured the distances to the sun and the moon, which and one of the most accurate figures of the day. He made magnetic observations, gravity observations, and he measured the Earth's radius. Now this is an interesting story, is they did the same in Paris, and they basically do a survey for about I think it's about 70 kilometers. They measure it by using survey techniques, and then they did the measurement, and then they did the same thing down south. So he started out in Cape Town, and he measured up to Aurora, just before Kastilberg, and he got a slightly different radius, so which means that the Earth was pear-shaped instead of round. He should have gotten the same answer as in the north. And only 100 years later, Thomas McClure, which we just heard of, he did the same survey, and he figured out why Lacaille got it wrong. Is some of the calibrations of your instruments, you actually have a plumb line. And he started out at Cape Town, so the mass of Cape Town was pulling his plumb line slightly this way, and he ended up just south of Kastilberg, and there the plumb line was pulled towards that. And that calibration error gave him a slightly wrong radius. So suddenly the Earth was round again. So, but he would probably be best remembered if you Google him, of these 14 new constellations that he named in the south. Because remember, back then there weren't, the southern skies have not really been explored. So he named them after the instruments of the day, sextant, compass, the lab instruments, a furnace, and all sorts of things. But the interesting one is actually a constellation which was called Mons Mensa. Mons meaning mountain. Forgot which is which. Mensa. Mensa is stable. Aha, thank you. Yeah, so that is Table Mountain. And it's the only constellation named after a geographical feature on the Earth. Very, very, and it's actually one of them, the big Magellanic Cloud is actually the tablecloth of Cape Town, above it, yeah. Just an interesting aside, Sir Herbert Baker, in just turn of previous century, they wanted to put up a plaque, and he was asked to do a to design the plaque, and this was actually the mock-up. And interesting, the swastikas. Swastikas, that was before Hitler, so swastikas was still okay by then. And that's actually what the plaque ended up being. And you can also see the sextant and also the survey there. Unfortunately, this plaque went the direction of everything brass in this world, and about 15 years ago it was stolen. So it's unfortunately not there. There was plans to replace it with a resin replica. I don't think that ever happened. Yeah. Okay. Yeah. So of course there were more and more need for accurate star positions, and on the 20th of October 1820, so that was 200 years ago, 2 years ago. The British Admiralty asked for actually the King's Most Excellent Majesty in Council authorized the Lords of the Commissioners of the Admiralty to cause an observatory to be erected at the Cape of Good Hope, and that became the first observatory, and that's actually the one that is still there today. So the first His Majesty's astronomer at the Cape was Reverend Fern Fellows, and he actually used one of these 1820 settlers' huts, set up his observatory in Cape Town first, and then later moved, once he picked the site, and in fact the instrument that he used, or one of his remaining instruments, is still in our museum in Cape Town. So again, you can see this telescope can just basically move up and down, although this one could rotate as well. One of the requirements of the site is that it had to be visible from Table Bay. So if the ships are in Table Bay, they need to be able to see the observatory. So one of the sites that he looked at was actually Tygerberg Hill, or the Koppie there, but ended up with this little hill called Slangkop in what's called the suburb of Observatory today, and that it could be visible from the harbour. So one of the assistants of when photography was invented. In those days, you had to be a chemist to be a photographer. So you had to mix your own chemicals, you had to apply it to a glass plate, and then you expose it. And he was actually playing with photography. And we think this is actually the oldest, or as far as we could determine, the oldest picture of an observatory anywhere in the world. And some of the oldest pictures of Cape Town was actually taken by this guy, Charles Piazzi Smith. And so that's just a comparison to what the observatory looks like today. So those two domes, they later got removed. They weren't really serving a purpose. And in fact, this is now being blocked up again. But there was a chase there, and on the other side, so the first instruments could only move north-south, and that's all they could do. And that was just, so the observatory was set up just to find accurate positions of stars. And these telescopes could only move north-south, and so the building would actually open up, and then you can see the telescope just in there, and that's a picture of it. And the reason for that is that you actually wait for the star to come across, and as soon as it goes, it crosses what we call the meridian, the north-south line, you measure the sidereal time, or you record the sidereal time, and that is actually the the right ascension of that star. Sorry, I've lost you all, but basically that's how they did the one measurement. And then the other one is, which we said was equal to latitude. They would read off these big circles. And that is the other measurement. And then you've got the position of those stars. And that's how they did it, sort of one by one. Later on, at the turn of last century, Sir David Gill, he actually painstakingly designed a transit circle that had all sorts of amazing accuracies built in, temperature compensations and whatever. And this was actually the most accurate way of measuring star positions up to about the 1960s, when satellites took over. So and this was replicated in a few observatories around the world later on. So so we've already mentioned the time, accurate time, and in fact, accurate time is a spin-off of any observatory. As soon as you've got an observatory, you can determine from the stars, from the sidereal time, you can revert that back to normal time. And so the observatory then became, and yeah, of course, we still find some of these accurate clocks in around the observatory today. They're actually called astronomical regulator clocks. And at some stage, the observatory, and we still have about half a dozen of these chronometers that, so the observatory was a depot for Herstmonceux Castle in England at the observatory there for supplying ships with fresh chronometers if theirs had any trouble. So the ships would be lying in harbour, and then Ferdinand Fellows actually, before there was a signal pistol, he actually went up on the roof with an oil lamp, and he would extinguish it exactly at 9:30 in the evening. So as soon as the light goes out, they will then check their chronometers. I always thought that they will be adjusting it, but all they do is when they're in harbour, they will just be rating their chronometer. So they will write down how much does it lose or gain. And then when you go out to sea, you know the rate of your chronometer, which you can then calculate every time you need to do an observation. And then later on, Henderson actually got the signal pistol, which he climbed up on the roof. So now they could do it during the day as well, because you see the puff of smoke. And then they could do that at night as well. You see the, you see the, and of course the noonday gun is a sort of a leftover from that as well. And you can see from 1806 already they were doing time signals, which all originated from the observatory. And then the telegraph was invented, which was the forerunner of the telephone. And as soon as they could do that, now they can remotely trigger guns. So from 1864 onwards, they could now fire the guns remotely, which is still done today. And in fact, the signal used to come by telephone line to the guns, but today we've actually given them instruments which now use GPS satellites for firing the gun accurately. So again, you can see the observatory on the hill here. You can see Piazzi Smith's, he was a very inventive guy. He actually had a windmill there and he pumped water up to the observatory. But what you should look at is that thing there, which is a time ball. And so if you, on the waterfront today is actually the time ball is there, and then on the observatory grounds, as you saw there were time balls, and then they had to move as they became difficult to see from the bay. And a time ball would have, yeah. So normally the ball would be at the bottom of that. The times which they were dropped actually changed over time, but at some stage it was 1 o'clock in the afternoon. So what you will have is that they will hoist the ball halfway about 5 minutes to, so then they know that there's going to be action soon, and then they raise it to the top about 2 minutes to, and then they drop it on the hour. And then that'll be observed, and of course there will be people ready with their binoculars or telescopes shouting to the person manning the clock. Now, what they probably had pre-drills, which they, yeah. So at some stage, the observatory supplied time to all the harbors in South Africa. Kimberley, I see it's been mentioned. Kimberley was obviously a big, important place back in the time with diamonds and stuff, and all the way up to Bulawayo was time signals, all originating from the observatory. So forever I've been at the observatory, we always had a time service. This one was taken out of service shortly after I started in Cape Town. And you can see a big electromechanical thing. This was our time service in Sutherland when I started there. That got replaced by a smaller one, which is computer based, and now it's a GPS receiver. So when GPS has got atomic clocks on board, so if you can just tap those electronic, not electronic, atomic clocks. So if you can just tap the clock, then you've got accurate time to nanoseconds, really. So this one here could get you to about a millisecond. This one can get you to about a microsecond. And then the very last one that my colleague built is about the size of this laptop, just slightly thicker. So so these are all based on GPS now. Yeah. And then lastly about tides, if you look at the oceans, so you've got two things pulling on the ocean. Of course, the sun and the moon, and then they always make a bulge on the other side as well. There's all sorts of theories which I haven't quite figured out yet, so don't worry. Just believe me, there's a bulge on the other side. You can see that there's 2 tides per day. So so in every 24 hours, there's actually 2. It's high tide twice and low tide twice. And of course, when it's on new moon, which is this situation here, the sun and the moon are pulling on the same side, and you have the bulge on the other side. And of course, with full moon, the moon's on that side. So the moon's pulling this way, the sun that way, and you get spring tides. And then at your quarter moons, first quarter or last quarter, you have now the sun pulling that way, the moon pulling that way, and then of course the tides are much less. It's neap tides. So the effect of the moon is about twice that of the sun. And because the moon rises 50 minutes later every day, you see that exactly same thing in the tides. The tides are 50 minutes later every day. And then there's a slight lag, and it's just because of the inertia of this huge amount of water that needs to be pulled. So you will see that spring tide is actually not on full moon or new moon. It's actually a day or 2 later. Yeah, a number of things, storms, you get a thing called a storm tide, where it will actually you actually end up with higher tides than what was predicted. Strong winds, if it's onshore, it will actually cause the high tide to be higher, or if it's offshore, you get especially the low tide to be lower. Well, the high tide as well. A high pressure system will actually cause exceptionally lower tides, and a low pressure causing higher tides than's expected. Your tides are always the greatest near the equinox, and we've just been 21st of March, which is the one equinox, and of course 21st around September is the other one, and that is quite often when you see floods as well, especially Somerset West Strand. You quite often see that being overflowing. And the so-called supermoon, which is another long story which I go into, well, that's just when the moon's the closest. The moon's orbit around the Earth is not round, it's actually slightly elliptical. So sometimes the moon are closer and sometimes it's further away. But the effect there is only about 5 centimeters, so it's actually not that much. So in the middle of the ocean, your tides are roughly a meter up and down. And there's a place in Canada where the tide, and of course it differs on different places on the earth. There's a place where the difference is over 16 meters between high tide and low tide. That's where you should put your generators for generating electricity. Yes. So this was just for Hermanus, and you can see. You can just get these on the internet these days, and you can see the difference in tides. And again, you can see now on the 29th, it'll be first quarter. So therefore, you can see this neap tide. The difference isn't very high. And then on the 6th of April, it is full moon, and you can see the difference. Also interesting that your alternatives are always high and low. And I always remember, it seems like at night, the sea was much higher than it is during the day. I haven't quite explained that yet. Maybe you guys who live here can figure this out. Yeah, and then of course, then it's third quarter again on the 30th, and you can see it's interesting that lot's lower is not that lot's lower as that. So there's this perpetual differences as well. Yeah, this rule of 12s, the rise of the water and the lowering isn't linear, as you can expect. So there's the so-called rule of 12s. So in the first hour, it'll move a 12th, the second hour 2 12s, then 3 12s for two consecutive ones, and then 2 12s. So basically, if you go to this chart and you'll see that, say there the difference will be about 1.2 meters or 120 centimeters. So that means in the first hour the sea will rise or low, depending if it's going high tide or low tide, with 10 centimeters. The next hour it'll be 20 centimeters, then it'll be 30 centimeters, 12, 20 and 10 again. So that's just so if you want to plan when you can get in and out of harbor, then you can factor this lot in. So in Sutherland we have a gravity meter, a microgravity meter, which is I'm not going to go into much of the details here, but it actually, so this curve that you see here is actually the Earth being pulled up and down as the moon goes over. So the Earth in Sutherland moves up by 40 centimeters when the moon goes across. So we think of the Earth being rigid, but it is actually quite pliable. Yeah.
Yo. Okay, now we are back to grade 6. I'm going to talk a bit about the use of satellite technology. Satellites have had a significant impact on our knowledge of the oceans. Here are some ways satellites have influenced our understanding of the oceans. And it's very, very important for this company as well. The tides, the weather, the migration of the animals. So for marine dynamics, this is very important as well. And there's lots of information that comes from the satellites, as you will see now. Oceanography, satellites can measure ocean surface, temperature, salinity, sea levels, ocean currents, and these data have enabled leave it out. To study and understand ocean processes on a global scale. Marine ecology, satellites can track the movement of the marine animals, very important, such as whales, sharks, sea turtles, providing insight into their migration patterns and behavior. Climate studies. Satellites have helped scientists monitor changes in sea level, sea ice, which are crucial components in the Earth's climate system. And then weather forecasting. Most of you are interested in weather forecasting. Satellites provide real-time data on ocean conditions such as temperature, currents, and waves, which is crucial for weather forecasting and predicting severe weather events. Navigation. Satellites are used for navigation and communication by ships and other vessels. This technology has increased safety at sea and helped to reduce the environmental impact of shipping. Overall, satellites have revolutionized our ability to observe and understand the oceans, providing valuable data that can be used for a wide range of purposes, from scientific researches to commercial applications. So guys, you can see the importance of satellites and the information that we can get from satellites that's applicable to our daily life and also applicable to marine dynamics and here at Kleinwaaien. Let's use a few examples. Navigation, GPS. And I don't think that you realize the influence of GPS on your daily life. If you want to go to Cape Town, if you want to go to Hermanus, what do? Put it in the GPS. Can you still work that old books, maps that we had? When last did you saw one of those books? So navigation, GPS, especially on sea, where you can see nothing except the sea, very important. AIS, automatic identification systems, and that is on board most of the vessels it's going to see these days, except the small ones. But the ships that's going past here, all of them got AIS on. And even the trawlers in Gansberg got AIS on. And the AIS is just, you can see on the screen exactly where you are and where the other ships and the ship traffic are. Except if you're a Russian vessel with a name called Lady R. Communication, voice and digital, very, very important. Of course, you don't want to be alone on the ocean, and sometimes it's necessary to communicate, to give messages, verbal or digital. 406 emergency beacons. That's the beacons that you put on board, and some of them activate automatically when something happens and seawater comes in contact with it. Some of them you activate by hand. And we'll talk about it now, but very important for safety is your 406 beacons. And then if we talk about science, the biggest satellite that comes to mind is ISS, the International Space Station. And you know that there's another one that they are busy, that's expanding as well at the moment. So there's two of them that is somewhere above us. And then of course, weather. And there's quite a few weather satellites in space at the moment. And I think that the NOAA satellites is most probably one of the ones that we know most, or so most that we know of and we hear about is the NOAAs, although there's lots of others as well. So if we want to see how it looks like, this is a typical example of a GPS satellite. Nothing strange. I think there's 26 of them at the moment. So this is a GPS satellite. AIS. This was an example of a good evening in Gansbaai. There was lots of fish in Walker Bay, and the whole of the Onderbaai, that is the guys from the West Coast, were here, and you can see the names of the boats. Can you? Yeah, you can see a bit. So that was quite chaotic, and there was about, I think it was 32 or 34 boats in this kolletjie here. just outside Gansbaai. Now the AIS, you get land-based AIS stations, and you get satellite AIS stations. And the satellites, of course, if you're too far away, this is working on 162 megahertz, so it's actually VHF, so it's pretty much line of sight. So if you go a bit further to the bigger ships, then you're out of reach of the land-based AIS stations. This one is actually mine, so this was received in the kelders. Communication, as I said, very, very important. And the one that we know the most of, most probably, is the Inmarsat system. It's a British satellite telecommunication company offering global mobile services. It provides telephone and data services to users worldwide through 14 geostationary telecommunication satellites. And I saw the other day that our friends from SpaceX are interested in this as well, and they did a few experiments on this as well. So most probably in the future we will have SpaceX that's on the bandwagon as well. Then back to the 406 emergency beacons. You can see they're quite high up, and if a signal comes in, they immediately relay it to search and rescue stations all around the world, and immediately they activate then search and rescue operations. Very, very important, and also very important that there's no false alarms. Immediately when they get the signal, they get the position as well. So don't try, they know exactly where you are. And then ISS. I assume that most of you saw ISS past here. Anyone? You saw it previously? ISS? Pass? Okay. If there's a good, nice pass, I put it normally on VMark for Gansbaai Lekker on Facebook. And there's quite a lot of people that's interested in it. What's nice about it is normally the pass is very, very bright. So it's not the normal ones that you see pass. The bright one is normally ISS. And, ladies and gentlemen, you won't believe me, but there's at all times about 6 people on board ISS. So it's not a normal satellite that's in the air, there's people on board it, and they did more than 3,000 different scientific experiments up to date aboard ISS. So you can see the importance of this satellite to us. Then I talked about the NOAA satellites. This is a photo of NOAA 19, launched on 6 February 2009 from the Vandenberg Air Force Base. Later on you'll hear again from this Air Force Base. Oh, and Willie told me, don't just speak about NOAA, it's the National Oceanic and Atmospheric Administration. That's what NOAA stands for. Thank you, Willie. Again, if you come back to VMark for Gansbaai Lekker Facebook, some of you saw the pictures that I put on about daily till the end of February. And this is a typical photo of the system that I use. So here on this side, we have the program that actually tracks the satellites, but it's doing another important job as well, and that is to give the correct Doppler effect data to the receiving program to correct the receiving frequency. And then when I receive this, the data is audio modulated. So I put it into a program, it decodes the audio, and it's actually very easy if you think about it. Black is a low tone, white is a high tone, and everything in between you can get the grayscale of it. So, and from here you can get things like temperature and the clouds and infrared and all the data that's in this signal. Unfortunately, yeah, I stopped at the end of February with it due to the noise level. Just lifted one day. So much so that there's about no signal coming from the satellite. That fault is not from the satellite, but from here. And that's a typical picture. I don't think we can talk about satellites without talking about the history of satellites in South Africa. So the first satellite that was built in South Africa, and now you must listen carefully, that words I heard previously as well. Oh, it was Zuma. Listen carefully. It's the first satellite built in South Africa that was in orbit. It's not the first satellite that was built in South Africa, but that's besides the point. So it was launched on February 23rd, 1999 from the Vandenberg Air Force Base. Again, the same as number 19. Now, me and Willie and Rix and Alma visited Sansa a while ago. Sansa Hermanus, I think you know it, Sansa Hermanus now. And after the visit, there's a quite nice place where you can play and mirrors and all that. And there's a mock-up of Santabila set. We'll come to that now. So we spoke to the guy and he said that Santabila set deorbited. So when we came back at home, obviously I did have a look and I want to know, where is Sunset? Is it still in orbit or did it deorbit? So, bear with me. Ladies and gentlemen, Sunset is still in the air. Sunset is still orbiting Earth. This is live. This is real time that you see on the screen here. This is the position of Sunset now. And at the moment it's 733 kilometers above us. Not well. It did not make his second year in space, unfortunately. There's two different theories that I know of why not. The one is a small piece of space junk went through it. And the other one is that when it was at end of life, or when it stopped transmitting, it was in an orbit where it was permanently in the sun. And it might be overheating of the batteries that caused its death. But although it's dead, it's still somewhere out there.
Space junk.
Yes. Lots of it. So of course this was built by the University of Stellenbosch. So, and if you have a look at it, it's looking like if space technology and satellites is actually in the Cape, in the Western Cape. Okay, the next one, Simbandila sat. And if I don't pronounce it correctly, it's okay. It's okay. It was launched on September the 17th, 2009. Simbandila sat is Venda, and it means lead the way. And again from Stellenbosch. The guy that was with the building of Sunset, Sias Moster, he was also involved in this one. Similar, not the same, similar. And then another era, CubeSats. So after those two, it was CubeSats. Now CubeSat is 10 centimeters by 10 centimeters by 10 centimeters. And that's a 1U, 1 unit. And then you can have a 2U and a 3U. But the 3U is a maximum. So it's 10 centimeters by 10 centimeters by 30 centimeters. So this one was our first CubeSat, a small one. Me and Willie visited them while they was building it at the, now I must think, Cape Town Peninsula University of Technology. Hell, I got it. And its name, Piso Sat, if that is correct, and it is Sutu for promise. But over time, thank you very much for listening to us. We hope you enjoyed it. And now it's Willie's time.
What?
Okay, so imagine having an asteroid named after you. It's like, welcome to the 6 o'clock news. 60% of Europe wiped out by violent currents. Wat was iemand gaan, die kurz is op pad. Dan gaan we, cool, nice lighthouse. Yeah, the asteroid. Well, that's amazing. Thank you guys. That was incredible. That's impressive. That was super. Thank you very much. Another round of applause. Okay, so this is not over yet. Have you got any questions? Any questions from the floor? Sure. Okay. Well, you can also... Well,
Yeah, it was a good presentation.
yeah?
How high is ISIS above the Earth?
It's about 430 kilometers.
Not so high.
Not so high. It's a low Earth orbiter.
Now we know. Thanks for that. Okay, so what we're going to do is we're going to enjoy the fantastic soup and bread that San Pasaki and a team from the Great White House they prepared for us. And then I know we've got cloud cover, but we'll see. So enjoy your soup, and then we're going to go to the back parking lot. It's nice and dark out there, and Henny and Billy and Johan will show us with the green laser what we supposed to be seeing behind the clouds, and then there will be 2 telescopes, and we'll have a look at what we can see. So before we do that, thank you so much each and every one of you for being here. Last week, Friday, oh Corin, come, you've got something and you want to give it. Give it. So just a little something from our side to say thank you so much for tonight, and thank you for all the information. So please come and get your lucky packets.
Ay, dankie baie. Okay, get on.
Yeah, I just want to
Right on here, right on here.
Thank you so much, each and
Nobody banner.
Ja, zie zo.
Marine Park trip, we were able to release another 4 penguins, and
Als hij, net voor je thuis.
the was found in front of a garage in France. 4 penguins, one that had a really serious bite. So we can only do that with more support. So we continue doing the conservation and the rehabilitation and the So thank you so much for being here. If you've got friends and family coming over for the Easter holidays, we do have a fantastic Easter holiday special. It started on Monday and it will continue until the 10th of April. So when you do go to our website, you choose book now, and then you select local prices because you are local, and then you have to make sure to select the Easter special add-on plus the conservation fee add-on. So please have a look. You want to have a break from your family during these holidays for at least 3 hours, send them to us. We'll take care of them. So let's go have some soup, and then we'll move to the back parking lot. We'll have the telescopes, and we'll have a green laser, and one back to you.